So now that we've covered computer terminology, and again, it's just a very high level, quick and dirty discussion of it. Read the book for, more specifics if you have the book, or be familiar with the terms. There's plenty of resources online. But I think most of you probably at this point in your life should have an idea of what a computer is and what makes up a computer. But let's talk now about programming terminology, and this is where you might not have as much experience. So let's go ahead and look at some of the terms that we're going to use in computer programming. So a program is a set of computer instructions that can be used to solve a problem. An algorithm is basically a generalized version of a program. Okay, it's not specific to any particular programming language or program. It simply defines a process, right? For example, a cake recipe is an algorithm, right? A recipe is nothing more than a series of steps that you take to solve a problem. In this case, your problem is, I want to make a cake. How do you make a cake? Well, here's the instructions for making a cake, right? That's your algorithm. You can write algorithms in pseudocode. Now, what is pseudocode? Pseudocode is something that's similar to a programming code, but we don't really worry about the syntax, right? We don't have to make sure that all of our commas and semicolons and everything are lined up perfectly. It's more human readable. You can look at it and go, oh, okay, I know what this is. It's kind of like the basic instructions without having to go into every little detail. It's kind of like our cake recipe, right? Your cake recipe tells you what to do, but it doesn't tell you exactly each step that you need to take to do all of the steps, right? When it says, preheat oven to 450 degrees, it doesn't tell you, turn around, take 3 steps, extend right hand with right index finger, hit button, so on and so forth. Okay, that would be more of the program. The pseudocode is going to give you the general steps that you're going to take, and you can, of course, refactor it and you can make it more specific and get that level of granularity if you want, but you often don't need to. So for an exercise, write an algorithm that finds the average miles per hour value for a given car trip. Okay, so your algorithm is going to take in, a starting location and a starting time. And imagine this on a point, on a line, right? It's the average miles per hour. And so we're going to write an algorithm that finds the average mile per hour for a given car trip. So we started at mile 100 and we're going to mile 200. And our start time was 2 o'clock and our end time is 4 o'clock. So what would that algorithm look like? Okay. And this is where I got the example from. So here's what our algorithm would look like. We're going to get what our start mileage is. We're going to get what our stop miles is. Start time, stop time. So that's the information that we need. And our total miles is going to be equal to our stop miles minus our start miles, right? And then our total hours is going to be similar. It's going to be our stop time minus our start time, right? And then our average mile per hour is going to be our total miles divided by our total hours. And that's what our average speed is. So this right here isn't any actual coding language. This is just pseudocode. This is just writing. This is a series of steps that we're going to take to solve this problem. So in order to write a program, we need to write it in a particular programming language. And a programming language is a language that uses specially defined words, grammar, and punctuation that a computer understands. Just the same as, English has certain words, grammar, and punctuation versus French or Spanish. Computer programs are no different. And there's a lot of different popular programming languages out there, Visual Basic, C++, so on and so forth, okay? We're obviously studying Java right now, but the things that you learn in this class will help you understand all of these, right? There is, these all have specific rules for their own language, but there's also general constructs that permeate any language that you're talking about, okay? So don't worry too much necessarily in this class about it being Java. We're going to build on that in the next semester, but focus on the fundamentals, and that's what the primary goal of this course is. Okay, so now we're going to take that, knowing that Java is a particular programming language, and we're going to write code that finds the average miles per hour value for a given car trip. That was the same thing that we did earlier with the pseudocode, but we're going to actually write it in Java. So what does that look like? Well, here is what the actual Java program looks like, right? And up at the top, we can see, hey, I wrote this thing, and here's our class called miles per hour calculator. And we're going to get into what a class is, so don't worry. And we're going to talk about all of this stuff and what that all means, right? And here we have our variables, and here we have we're doing some work, right? We're doing some math and stuff, and then we're doing some more math, and then here we're printing out something, right? So this is the same thing that we did in pseudocode, but this is done in actual code, all right? So this is a programming language, and if we were to execute it, that's what our answer would be. So again, comparing the two things, we have our programming language over here versus our algorithm over here. And you can see how similar they are. And that's one of the things that's key about writing pseudocode when you're defining your algorithms, is it really makes it easy to translate between this over here, once you know what you're doing, to this over here, and says, oh, okay, now that I know the general constructs of what I have to do, all I've got to do is to write it within the rules and the grammar that Java says you have to write it in, okay? So if we were to take away all the other junk on the screen and look at this again, you can see how we're defining some inputs here. We're saying we need to get some information from the user, right? Or we need to put in some information. We can see how that directly corresponds to this section right here, right? We can see how this total miles is equal to our stop miles minus our start miles. You can see that corresponds to that line right there, and this line right here. And you can see how our average mile per hour calculation is done right here, and our print is done right here. So it's almost precisely a one-to-one translation from our pseudocode to our actual program. Now, it's not always going to be this clean, and of course this is a trivial toy problem, but again, it's just to reinforce the value of writing pseudocode. You don't have to worry about, when you're writing your pseudocode, you don't have to worry about whether or not you've got this semicolon in the right place, or that you've got this method header written correctly, or hey, are my braces on my classes and methods, you know, appropriate? All right, you don't have to worry about any of that. Over here, you're just focused on, am I doing the right thing? And it can help you a lot. So you have your program, right? You have it written out. You're like, okay, I know what I want my computer to do. And then you want to actually do something with it. You want to actually achieve something. So there's two parts to that. Number one is you have to actually compile the program, right? You have to translate the text that you've written into something that the computer can actually understand. And that's what the compiler will do. Running the program will actually take the instructions that have been compiled, you know, the ones and zeros, and actually start executing those commands on the computer. So what exactly does the compiler do? Well, it converts the source code, as I said, for a text file into object code, which is binary, and those are important terms to remember. Source code is your original text document that you type out, and object code is what you get after compiling a program. And some programming languages aren't actually ever compiled, and they're interpreted, which means it goes line by line and it reads it and then translates it and then executes it right away, whereas a compiled program has to be compiled first. So like HTML, when you run an HTML code in a browser, it goes line by line looks at what you're telling it to do and then does it and then goes on to the next line, versus a compiled program, which it reads in the whole program, translates it into object code, and then you have a separate file, and then you can run that file. So that's the difference between compiled and interpreted. Okay, and different compilers can behave differently. So when you're compiling a program, you can compile it to be optimized, or you can compile it to be more beneficial to debugging, right? So that's going to change the output of your program depending on what you want to do. So typically when you compile a program, you're going to leave all the debugging flags on, so you have different outputs to your screen and this and that, and then you can, once you're happy with your program, you can run an optimized debugger, which will give you a much smaller file, and then without as much different flags and different things sent to the user for output, and so on and so forth. So this is something that is more critical when we're talking about C++ especially, but it applies to Java as well. So let's break down the compilation process for a non-Java program. Again, this is a non-Java program. We're going to take the source code, which is the instructions that you're writing out, okay? And we're going to send it to the compiler. And the compiler is going to take that code and translate it into object code, which is binary instructions. And then the computers run it, okay? Are we good on that? Okay, now remember, this is a non-Java program. Java programs work a little bit differently. So if I haven't made clear already, object code is binary, all right? And a binary format instruction is going to be all ones and zeros, because that's what binary is. But if you look at this one right here, this is a 16-bit instruction, because you can see that it actually has 16 bits, right? Each instruction is going to tell the CPU to do something different. So doing a simple calculation like add two numbers together is actually going to take quite a few instructions to tell the processor to, grab some input, put it in a register, grab the other input, put it in another register, tell the arithmetic logic unit to take over and actually calculate the difference of the result and store it into a third register, and then take that register and stick it into memory. So this one instruction is going to tell the computer to do that, but it depends on the number of bits that are involved. Okay. Because of the level that these things operate at, object code is often referred to as machine code, because some programmers probably back in the 60s when they were first working on these things could probably actually tell you what this instruction was right here, right? Somebody could probably tell you that, oh yeah, that's an add instruction to take register A and add it to register B. Okay, not many people these days can do it. Maybe if you're working at the bit level, but you don't need to. Okay, so this is called machine code. We also need to talk a bit about portability. What is portability? Well, a piece of software is said to be portable if it can be used on many different types of computers. And as you know, with object code being comprised of binary format instructions, they have to be written specifically for a particular instruction set or a particular hardware realization. So if we're writing a C++ program, we have to compile it for, say, 32-bit Windows, right? Or 64-bit Windows or something else. So object code isn't very portable, right? You can't just take one computer's object code and go run it on a different operating system's computer. It won't work, right? So Java is different because it doesn't compile to object code. It compiles to byte code, okay? And so this process means that there's an extra step in how the code gets executed and run, but it makes the Java code base very portable. So then the question is, how does Java do things differently? How can bytecode be run on any different computer? Well, Java uses the Java virtual machine to process the bytecode. All right. So let's take a look at how that works. We take the Java source code, which is just like our other code, right? It's just text document that you write. And we compile it into bytecode. All right. This process is the same, but instead of going to source code, right, where on the other one this would have been source code, right? We're not doing source code. We're doing bytecode. And bytecode is differently because it's a common set of instructions that are then processed by the Java virtual machine. And the JVM translates that to the particular operating system and converts it into object code, which the computer then runs. So each JVM is designed for a particular computer and whatever else. So it takes the job of compiling it for that particular OS. So you're going to have a Windows JVM, right? You're going to have a Mac JVM, right? You're going to have a Linux JVM. Okay? Those have to be installed on the computer, and that JVM takes this bytecode and translates it into objects code. So you only have, as the programmer, you only have to worry about one thing, and that's writing your code. This stuff down here, this process, is handled by nerds that are, they're writing instructions for the computer and the operating system, okay? That goes beyond my level of expertise in actually doing that. Nor do I have any desire to, because I don't find it very interesting. But there's people out there that actually have to program these JVMs to take their particular operating system's instructions and figure out how to take your bytecode and convert it to that particular operating system. You, as the software developer, don't have to worry about that. You just have to worry about writing your code, and it can run on any particular system. So it's kind of cool.